Today we will be working on classifying quadrilaterals and triangles when they are on a coordinate plane. So in other words, when you have some sort of quadrilateral or some sort of triangle graphed, and they ask you what type of quadrilateral or what type of triangle is it, you will be able to answer that question by the end of these notes. So make sure that you have the warm-up that you just finished with you and out while you are kind of learning and watching this lesson, okay? Before we can go into the examples for today, we need to review a couple things, and then we're going to do some prep work. So we're going to go over some things to look for whenever you see these types of problems, okay? So the first thing that you need to be aware of and remember are two different formulas, because they're going to come up pretty much in every single problem we do. So the first one is the distance formula. So remember, the distance formula tells you how far 2 points are away from each other on the graph. And another way of thinking about it is it would be, since we're dealing with figures or shapes graphed in our coordinate plane, you can think of it as like the length of a side as well, okay? And so that will be good. And then don't forget, you can use the formula, but also you could use Pythagorean theorem, especially on graphs. Pythagorean theorem is really easy to use to find the distance between 2 points, okay? So now the other thing that you have to remember is slope. So slope has a formula, and so you can take the 2 points, and to find the slope, you could plug it in this formula, or if it's on a graph, a lot of times it's easy to think of slope as rise over run. And what that means is you're asking yourself, how much do you go up or down to get from one point to the other, and then how much do you go left or right to get from that point to the other, okay? And so we will be using both of these concepts throughout this entire lesson, all right? So something else that you will need to make sure that you know or you review before you start this lesson is, remember, distance is the length from one point on the graph to the other, which we kind of just talked about. And then also with slopes, we are going to have to tell if two things are parallel to each other, and we're going to have to be able to tell if things are perpendicular to each other as well. So remember, parallel means that they never cross no matter how far you extend it. And then remember, perpendicular are when lines cross to form right angles, okay? And so some things with that is to remember that parallel lines have the same slope, and then perpendicular lines have what are called negative reciprocal slopes. So that means that the signs are different from each other, and then the fractions are flipped, okay? So you've got to make sure that you're good with all of this before you move on, all right? So some prep work for this lesson. When they give you a quadrilateral, remember a quadrilateral is a four-sided figure. When they give you one of those and they ask you to classify it, it's going to be good to think about in a certain way, all right? So let's say, we've kind of have a flow chart to kind of help you think through the way to approach the problem, all right? So the first thing is you're going to be given the quadrilateral. So this is your quadrilateral that you start with. So I'm going to label it with your quadrilateral. And so remember, quadrilateral means that it has four sides. And if you're looking at that little warm-up, you can kind of look through it and just refresh your memory. So quadrilateral just has four sides. Once you look at it and it has four sides, then you're going to look at one direction or the other to figure out if it's a more specific type of figure. So if it has four sides and there's two sides that are beside each other that have the same length, and then there's two other sides that are beside each other and they have the same length. And so notice the marks that I put. If I put the same, I call them little tick marks. If I put the same number of tick marks on the side, that means that they have the same length. If they have two sides that are next to each other with the same length and then two other sides that have the same length, this is what's called a kite. So it is a more specific type of quadrilateral, okay? So that's a kite. if you're looking at a figure and the opposite sides are parallel to each other, and to show that they're parallel, you put an arrow on each one and you put the same number of arrows. So like this, if I was looking at this picture, I would know that this is parallel to that. If they just have one set of opposite sides parallel, then that's called a trapezoid. Okay, and so that's also a more specific type of quadrilateral. All right, now the last category can kind of branch off into other things, and so we're going to spend a minute on this one. All right, so if you look at the figure and you notice that opposite sides are parallel, so that side's parallel to that side, but then this side, so I'm going to have to put 2 arrows to show that it's different than that. So if this side is parallel to that side and the opposite sides are the same length, so I'm going to have to put this kind of to the side, then that would be called what's called a parallelogram. So if opposite sides are parallel and opposite sides are congruent, you have a parallelogram. Okay? Now, that the opposite sides congruent is a property, so I'm actually going to erase that because we're just going to deal with the definitions for right now. But that is a property that it has, so that's something that's good to know. Okay, so if the opposite sides are parallel, it's what's called a parallelogram. That should make sense. But you can actually get more specific than this. So if you're looking at it and on top of the fact that the opposite sides are parallel, if it has 4 right angles, in other words, all of the sides are what's called perpendicular to each other, then that would be called a rectangle. So if you're looking at it and all the angles are right angles, and like notice in a rectangle, all of the sides aren't equal, just the opposite sides, right? If you notice that it has 4 right angles, then that's a rectangle. Okay. Now, what if it doesn't have 4 right angles? Well, another more specific type of parallelogram you could have is if you look at it and you find the lengths of all the sides and all of the lengths are equal, then that would be called a rhombus. And so it's still a parallelogram, but it's more specific because on top of the opposite sides being parallel, all the sides are actually equal. All right. Now, the last one, and it's the one that everybody kind of knows about, is, well, what happens if you look at a figure and it has all the sides equal? So we kind of combine these two things. But on top of that, it also has all right angles. Well, that is what you call a square. Okay, which is the most specific type of quadrilateral there is. All right, so when you are looking at a figure, look to see if it has 4 sides first. Then, to figure out which one it's going to be from there, you can look to see if it has 2 what are called adjacent sides that are equal in length, or one set of opposite sides parallel, or both sets of sides that are opposite parallel. Okay, and that'll kind of help you to begin with, and then from there, if it is a parallelogram, then you have to kind of look from there. So if it's a parallelogram and all the sides are equal, then it's a rhombus. If it doesn't necessarily have this going on, but it has 4 right angles, then it's a rectangle. And if it has both of these things, then it's a square. Okay, so let's practice with that concept, and then we'll get to some of the problems that you will have for today. Okay, so with these examples, I've actually given you a figure, and then I've given you the slopes, and then I've given you the lengths of the sides. Okay, so it says we have a quadrilateral bear, so they labeled it. All right, so the first thing you're going to do is draw a general 4-sided figure, because it says it's a quadrilateral. So you're going to draw just a general 4-sided figure. Try not to be too specific with the sides, just draw 4 sides, okay? Then we're going to label it. So bear, you have to go around in a circle, so B-E-A-R. And then you're going to look at the information it gives you. So the first thing that we want to look at is you can look at the lengths first, or you can look at the sides that are parallel. It might be easier to look at they're parallel or not. Okay, so that would be the slope thing, because remember, parallel lines have the same slope. So for instance, if I was looking to see if it's a parallelogram, I'm going to check the opposite sides and see if they have the same slope. Okay, so I'm going to label my slopes around this figure. All right, so BE has a slope of 1/3. EA has a slope of -3. AR has a slope of 1/3. And then BR has a slope of -3. Okay, are the opposite sides, do they have the same slope? And notice they do. So that means my opposite sides are parallel. So we know just from looking at the slopes that it's a parallelogram. Okay, now we're going to look to see if it's any more specific than that. So does it have all sides equal? Does it have 4 right angles? Or does it have both of those? All right, so how do we know that? Well, to see if they have all sides equal, we're going to look at the lengths of them. And so notice the lengths of all of my sides are all whatever the square root of 10 is. So because all of the lengths are exactly the same, and I don't know why, because all the lengths are exactly the same, that means that it is at least a rhombus. Okay, so now how do we tell if it has right angles? Well, remember, lines that cross to form right angles are perpendicular and they have negative reciprocal slopes. So to see if these lines are perpendicular to each other, in other words, we have right angles, I'm going to check the slopes of the lines that connect. Okay, so like if I take this one and then I compare it to the slope of this one, if they are negative reciprocals to each other, then that means that this angle is a right angle. So I'm going to take one of them, I'm going to flip it, so I'm going to just flip that one, and then I'm going to change the sign. Is that the same as that? And it is. So these are negative reciprocals, which means these cross at a right angle. And then if you look at these two, it's the same story. So those two lines cross at a right angle. Same story here. So these cross at a right angle, and then same there. So what is this? Well, if I look at it, all the sides are equal. It has 4 right angles. So that would be a square. Okay, now remember at the beginning I just drew a general shape, so you have to not go off of your picture. Okay, but this figure is a square. All right, so let's do one more and then we'll go from there. So in this one it says classify quadrilateral OHMY where, and it's given us information. So I'm going to draw my general quadrilateral again. Okay, and then I've got O H, M, Y, and then I'm going to compare my stuff. All right, so again, you can start with the slopes. So the slope of OH is -1/3. The slope of HM, and I'm just labeling it as -3. The slope of MY is -1/3, and then the slope of OY is -3. Okay, so I'm going to start by looking at my slopes. First of all, it's easy to see, are these parallel? So are my opposite slopes the same? And yes, so I know I have at least a parallelogram. So I'm going to label it so that I know that my opposite sides are parallel. But then I've got to see if it's more specific. So now I start looking at the length. So OH is √10, whatever that is. HM is whatever 2 √10 is. And you could actually type that in if you wanted the decimal. MY is √10, which is not the same thing as this one. And then OY is 2 √10. So notice in this problem, all the sides aren't equal. So that means I know at least it's not a rhombus or a square, because they don't have all the sides equal. So I know it's a parallelogram. So now I just have to see, is it a rectangle? Will it have right angles? Okay, so I'm going to look at my slope, because to have right angles I have to have negative reciprocal slopes. So I'm going to look at the ones that are beside each other. So if I take, for instance, this one and I flip it, so it'd be a 3/1, and then I change the sign, so that would be a positive now. Do I get that one? And notice that's not the same thing as this one. So these are not negative reciprocals of each other, which means they are not perpendicular to each other. So, and it's the same story all the way around. So that means I don't have right angles. So then what is it? Well, didn't have congruent sides, didn't have right angles. So the most specific I can be is it is a parallelogram. So this one is a parallelogram. So this is how you're going to approach the problems. You're going to graph it, and it'll make it easier when you graph it, and then you're going to find your information and then classify it from there.